Welcome back. In part 1, we explored what depressions are and how they affect flight conditions. In this episode, we'll focus on the development stages of depressions, occlusion processes, and how pilots can operate safely around these systems. Let's begin with the life cycle of a frontal depression, also called a mid-latitude cyclone. These systems typically evolve through 4 main stages: formation, development, occlusion, dissipation. The formation stage occurs when a disturbance forms along a stationary front. A slight kink or wave develops as air masses interact. This is the birth of a new low-pressure system. Next is the development stage. The cold front begins to advance faster than the warm front. The system deepens, pressure drops, and winds increase. This stage is when pilots experience the most active weather. The warm front leads with layered clouds and steady rain. The cold front follows with heavier showers, CBS, and gusts. The pressure gradient tightens, making for strong winds and turbulence, especially at low altitudes. Then comes occlusion. The faster-moving cold front eventually catches up with the warm front, lifting warm air aloft. The warm sector disappears from the surface, and the depression enters its most complex phase. There are 2 types of occlusions. Cold occlusion. Cold air behind the front is colder than the air ahead. Warm occlusion. Cold air behind the front is warmer than the air ahead. Both lead to multilayer cloud decks and unstable flying conditions. At this point, the system begins to weaken. That's the dissipation stage. The pressure rises again, winds ease, and precipitation becomes more patchy. But don't relax too soon, residual weather can still impact flight ops. Let's explore occluded front weather. It often brings multi-level clouds, embedded CBS, freezing rain, variable visibility. Turbulence. Pilots flying through this zone need strong situational awareness and careful altitude selection to avoid ice and storms. Let's walk through a flight case. You're en route from Dublin to Zurich. Forecast charts show an occluded front near Belgium. Significant weather charts predict embedded CBS between FL 100 and FL 200. You plan a route detour to avoid the frontal zone. File alternates in warmer air masses. Add fuel for potential holding delays. Let's now review weather chart reading for occlusions. On a surface chart, an occluded front is marked with purple lines and alternating semicircles, triangles. Watch how it bends around the center of the depression. Use TAFs to identify occlusion effects. OVC 010 with +RA or SN. Visibility between 300 and 1000 meters. Wind shifts or variable gusts. These help assess how deep or active the occlusion is at your destination. Occluded fronts also affect climb and descent performance. Passing through dense, moist layers means risk of airframe icing, carburetor or engine inlet icing, low climb rate due to turbulence or heavy precipitation. Plan vertical profiles conservatively in these situations. Autopilot use in occluded front. Turbulence must be monitored. Sudden pitch or roll inputs can happen during rapid wind shear or downdrafts. Always stay ready to disconnect and fly manually if needed. Now let's connect this to flight planning strategy. Before departure, ask: is the depression strengthening or dissipating? Where is the occlusion located at my ETA? Can I reroute around the frontal zone? What's the best altitude to avoid icing layers? Use satellite imagery to spot occlusion structure. Infrared shows cloud top temperatures, colder tops equals stronger activity. Combine this with radar and SIGMETs to get a full picture of frontal strength. Let's talk about pressure gradients. The closer the isobars, the stronger the winds. Around a deepening depression, expect low-level wind shear, especially near terrain or during descent through unstable layers. Also check the jet stream location. A strengthening depression often sits beneath or near a jet streak, which can intensify upper-level winds and trigger turbulence. Use wind charts to avoid strongest segments. Pilots should also assess alternates carefully. Depressions often cover wide areas. Make sure your alternate isn't under the same frontal zone. Choose fields outside the system or in better air masses. And always brief for possible go-arounds. Visibility and sealing near occluded fronts can change quickly. Be ready with missed approach procedures and contingency fuel if landing isn't possible on the first attempt. Let's recap today's episode. Depressions evolve through formation, development, occlusion, and dissipation. Occluded fronts bring complex cloud layers and icing risk. Use charts, satellite, and wind data to evaluate frontal position and severity. Stay flexible in planning and ready to divert or delay if needed. In the next episode, we'll explore the big picture, global climatology. You'll learn how major climate zones shape long-term weather, winds, and seasonal changes that influence aviation worldwide. See you in Meteorology number 42, Global Climatology, Part 1.